Very good afternoon to you and welcome to the latest in our series of HOP webinars. HOP stands for the Hertfordshire Opportunities Portal. It is a website that we hope every school and every student in Hertfordshire and the surrounding areas is aware of, because it is a one-stop shop with a whole host of resources that will help you with your future career decisions. These virtual webinars are just one of the resources on there. I will share with you a couple of links as we go through this webinar though, about how you can find all the previous webinars that we've recorded. So a bit of housekeeping first of all. For those of you that are here and joining us live, and I know there are a few of you on the call at the moment, it is 4:30 on Thursday afternoon. Firstly, well done for coming home from school or for college, for registering to attend and turning up on a webinar. I know there are probably lots of other things that you might want to do when you come home from a busy day at school, but really investing time into think about your future career is very, very commendable. So well done for you that are watching this live. If you are watching it live, it means you've got the opportunity to interact with us. So we can't see or hear any of you, but you can submit your questions to us. And the way that you do that is on your dashboard, on your screen. You should see that there is a tab on there that says questions. If you open that box out, so it's probably the little square box next to the cross, that will open out a text box. You can type that question in and it will come through to me. It won't be visible to anyone else. It'll only be visible to me. And then I can relay that question onto our panelists for you, who I'm going to introduce in just a moment. So do make the most of that. This session is being recorded. So if you can't stay with us all the way through, and we'll probably go through till about 5:15, about 45 minutes, it is being recorded. It will be available on our HOP Virtual Encounters library. It should be uploaded from tomorrow, but if you have a look at that, I want to say you'll have access to, I think it's nearly about 100 of these that we've recorded, covering a whole host of different topics. But our topic today is something that I know very, very little about. I'm going to be honest with you. So I'm going to be as enlightened as the rest of you will today. We're going to be talking about chemical engineering today, and I'm delighted I've got a fantastic panelist who's joined us, who is Sarah Button. So Sarah, thank you so much for joining us. Could I ask you, first of all, just to tell everybody a little bit about yourself?
Sure, thanks, Gareth. Thanks for inviting me. So yeah, I'm Sarah Button. I grew up and went to school in Lincoln, and I decided to study chemical engineering when I did that at Imperial College in London. So I was there for 4 years. I did an undergraduate master's. While I was there, I also got involved with the Engineers Without Borders Society, and helped to set up a charity called Raincatcher. So both of those are international development charities using engineering skills to solve problems on the ground, and in this case, water and sanitation in Tanzania. So after I graduated, I joined Johnson Matthey, which is quite a large company that nobody's heard of. So it is a FTSE 100 company in the UK, or it has been. It sort of bobs around at the bottom of the FTSE 100, and it's a sustainable technologies company. So I was drawn to their vision of creating a world that's cleaner and healthier today and for future generations. And really that is why I chose to study chemical engineering. So I really felt the company's vision aligned with my values. So since I joined, I've worked across several areas of the company, almost all of the different parts of the company actually, doing a variety of different roles in chemical engineering, and then more recently, more technical and commercial roles. So some examples of roles that I've done are designing chemical plants, so factories that make materials for battery electric vehicles, for example, or I spent some time on a team working out how to scale up a product which would extend the shelf life of fruit, which is like those little tiny strips you sometimes get in your packet, in your punnet of strawberries. Working out how to scale that up from the lab to a manufacturing facility. And then I did a commercial role trying to sell catalyst for fertilizer plants, which is made out of pure platinum. Currently, I'm working in a business development role, which is also has a technical slant to it. in green hydrogen. So Johnson Matthey makes components for electrolyzers, which produce hydrogen from water. So green hydrogen will be a key driver in getting us to net zero, getting the world to net zero, particularly in industrial feedstock.
Sure.
So sorry, that's quite long.
No, you've given us lots there to try and delve into. And so if you do have any questions as we're going through, do put them into the questions tab, and I'll make sure that we get those questions to Sarah. But Sarah, first thing I'm going to ask you, and I'm sure our audience will know more than I do already, but just for the sort of sake of context, can you just tell us, what does an engineer do? And then where does chemical engineering fit into that, I guess, that broader engineering theme?
Okay, so this is the Sarah Button definition. I'm sure Google is going to have a much better definition, but I think engineering is solving problems using the fundamental principles of maths and science. So practical problems, the application of maths and science. Obviously, there's lots of different branches of engineering. So there's engineering of buildings, and big structures, which is normally called civil engineering or structural engineering, aeronautical or aerospace engineering, which is planes and rockets broadly, mechanical engineering, which is, I would define as engineering of things which have moving parts, solid things, and chemical engineering, which, to say it's the engineering of chemicals, I think perhaps doesn't give it enough. It isn't quite enough, but I would say that chemical engineers generally are responsible for designing processes which transform raw materials into a finished product. Typically, the process will involve handling of liquids and gases. Mechanical engineering, I always think, deals more in solids, whereas chemical engineering, in most processes, not all, will involve the processing of liquids and gases in some way. So those products for chemical engineering could be anything from literally energy that powers homes, vehicles maybe, to food, drink, pharmaceuticals, healthcare products, all things you find in your house, so paints, plastics, your clothes, paper. So we're literally surrounded by things which chemical engineers have helped to produce.
Sure. Okay. Well, that's really helped me understand a little bit more about what chemical engineering is. And I mean, it sounds like chemical engineering is probably a perfect marriage for you in a couple of interests, and intrinsically, Sarah. So you talked about, that problem-solving aspect of it as well. And I know you've already alluded to it on this webinar. You've got a real passion, haven't you, for sustainability in the environment. So can you just tell us a little bit, if we go back to sort of 15-year-old Sarah, and your interest in the environment, how does that manifest itself into you then wanting to go into study chemical engineering?
Sure. So yes, I've always been concerned about climate change and about my future and the future of the rest of humanity and future humans who haven't been born yet as well. So it's always something that I've been concerned about. And I think when I was trying to decide what to study at university, I wanted to go into a career which was helping build a sustainable future for humanity, really. And when I found chemical engineering, because I really didn't know any chemical engineers or any engineers at all, but when I discovered chemical engineering on the internet, basically, I felt that it would be a good way to find a career in sustainable technologies, or technologies which were helping us to reach a sustainable future, or what I now know to be driving us towards net zero carbon emissions, which is what we need to get to by 2050.
Yeah. Okay. And yeah, you've proved that you are younger than me by the fact that you did your careers research at school on the internet. I didn't have access to that. It was a slightly more rudimentary process. But so tell us about what you did after your GCSEs, the subjects you did, and what was your thinking behind those?
So when I was doing my GCSEs, I hadn't decided that I wanted to be an engineer. So I just followed what I actually wanted to do was try to keep my options open. And I realized that more technical or STEM degrees were more specific about which A levels they required. And for that reason, I decided to do more STEM A levels because I was also interested in history and English at GCSE level as well. So I chose to study for AS, or I don't think we still have AS levels, do we? But I
I
did,
think we do. Yeah.
I did AS levels, and I did maths, physics, chemistry, and history. Um, and then I did dropped history and just did maths, physics, and chemistry at A level. Um, and it was at that point that I realised that I wanted to go into engineering.
Yeah. Okay. So you then, I know you then said that's when you did that online assessment, didn't you, of your future career choices, and that's where the concept of chemical engineering was really laid in front of you. So what were you looking for? You obviously went to university, so we'll talk about university. We'll talk about non-university options as well a little bit later. But from a university perspective, what were you looking for in a course, and how did you choose the course that you did?
Okay, so once I'd chosen chemical engineering, or do you mean before how did I select the course?
Yeah, how did
Select
you?
the
I'm guessing there was probably a choice of different chemical engineering courses that you could have done. So
okay.
was it around the location or the venue of the university, or was it the type and the makeup of the course?
Now, the answer to this question is going to be a bit outdated because actually there was only about 6 universities that offered chemical engineering at that point back in 2005 or 6 whenever I applied. And that has changed, I believe. So a lot more courses and a lot more universities offer chemical engineering. Some considerations were that the Oxbridge universities, Oxford and Cambridge, neither of them offer chemical engineering in the first year. Chemical engineering was accessed via either the natural sciences route or an general engineering route, which wasn't something that I wanted to do. I'm not sure why in hindsight, I think, but I was very set on just doing chemical engineering and nothing else. And then, yeah, there's a lot of other universities. I looked at all of the universities, I think, that offered chemical engineering. And in the end, I decided I wanted to go to London, basically. And Imperial College offered a very highly ranked course. And I felt like for me, I didn't want to go to a campus university. I wanted to go to a university in a real place where I was mixed in with everyone else, not just in the uni bubble, as they call it.
Sure. Yeah. Okay. And then you mentioned to me beforehand that possibly if you went back in hindsight, you might have done a more general engineering degree course. Why is that? What do you think you would have gained from?
I think since getting involved in, I guess, climate change mitigation technologies, I've learned that yes, chemical engineers have a huge role to play, but there are also big roles for the other engineering disciplines. I guess I've had a few friends who've done civil engineering, and I think the impact of what they call the built environment on climate change and also on human well-being is enormous, and so that's always really fascinated me. So I think, yeah, if I could go back, maybe I would do civil engineering. Maybe I still will one day, who knows.
Yeah.
But I don't regret doing chemical engineering in the slightest. I think there's a whole world of opportunities and possibilities.
Good.
It's
Okay.
not as narrow as it sounds.
We'll talk a little bit more about courses and universities and pathways in a little while. Just want to ask, I mean, thinking back to the discussion, I know you're not by job title a chemical engineer now, but thinking back to when you were a chemical engineer on a day-to-day basis, what did the average day look like? What sort of things were you doing? I mean, is the picture we've got on the screen there reflective of the sort of things that you were doing?
So yes, in part, I have definitely done things that the lady on the screen is doing. So an example of that would be when I worked in a role where I was designing chemical plants. I spent a lot of time in the office on my computer and working with teams with enormous pieces of paper, designing out where all the pumps and the reactors should go in the chemical plant. But then sometimes I would go and visit the customer who had built the chemical plant or was in the process of building the chemical plant, taking all these drawings with us, and we would check what had been built against what had been drawn, what we designed essentially. And so, yeah, I'm sure I looked very much like the lady in the picture. But equally, sometimes, spending a lot of time in the office, also potentially time in the lab, working with chemists perhaps to develop new processes. I've also been involved in operating what are called pilot plants, which are like small scale chemical plants, which you would use for product development to develop a new process. So operating those plants and helping to design them. And I guess chemical engineers also might be involved in entrepreneurship, developing starting their own business. I think a chemical engineering degree or any engineering degree will equip you with some really good skills for starting your own business if that's what you want to do, and maybe bring a new innovative product to market. And that, I suppose, is closest to what I'm doing now. I'm working in a startup environment, but within a bigger company.
Okay, so you've talked about some of the things that you might have done on a day-to-day basis. So, I mean, the question's in two parts. What were the aspects of that you found most enjoyable, and then what were the most challenging parts of that role that you had to do that you think maybe people should be aware of if they're thinking about this as a future career? There's always that warts and all stories, and there's always those things that people don't consider properly.
Yeah, absolutely. And I mean, obviously, there's just a huge spectrum of different career paths, of course. So for me, the most enjoyable parts of my job have always been when I have felt that I was contributing in a practical way towards getting the world to net zero carbon emissions. And I've tried to choose roles that have done that as much as possible, and I find that really motivating. So for me personally, the most enjoyable aspects will normally involve interacting with other people, be they my colleagues or perhaps with a customer, or previous roles I've had, I did a lot of interaction with suppliers, and trying to solve problems together. So either internally or between our company and the customer, and really seeing how we can kind of create value together. And doing that will often involve a lot of analysis of the problem. It might involve going to their chemical plant and having a look, looking through their drawings, analysing data, doing some computational modelling perhaps, or working with people who do that, or conducting some testing or some experiments to prove out a hypothesis that we have. I'm working in business development now, but these are activities that I do daily, or work with teams who are doing daily. So yeah, I think I enjoy a lot of different aspects. The second part of the question was about challenges. So I feel like every day has been a new challenge, and there's a lot of variety, and I think that is typical of chemical engineering careers. But some examples of challenges that I've faced in chemical engineering, I'm not sure if I can think of any general ones that you should look out for, but I can give you some examples of challenges I've faced. So an example, when I was on a chemical plant, helping the customer to start up a chemical plant that we had designed, was trying to persuade the customer that they should follow a vital safety procedure, which was going to take extra time and cause them to be, in their view, a bit delayed. They were trying to go as quickly as possible, but as part of the commissioning, so the startup process, we designed, you have to follow this safety procedure, and so we had to persuade them and explain why it was important. So that's always stayed with me, of like, it was a tense time.
Sure.
Other things, challenges can be when things go wrong. So particularly chemical engineers are going to get very involved in safety. Safety is going to be a big part of the job. Everyone should, go home from work the same way that they arrived at work and be safe and healthy. And a lot of the time, chemical engineers are dealing with processes which can be, if they go wrong, can be dangerous. So there's a lot of challenge in working out safety system. It's a whole branch of chemical engineering, is process safety engineering. It's a whole profession. So yeah, those people are working out all the different things that could go wrong and working out how to design the process so that if one thing does go wrong, then the process will be made safe by a safety system, which will be alarms, what we call trips, to make it turn off basically if things get out of control.
Sure. Okay. All right. So, like I say, for those of you watching live, if you want to ask any questions, anything you want Sarah to elaborate on a little bit, or you want to clarify, do get those questions in. You go to the questions tab on your dashboard. It opens out a text box. Type your question in there. It'll only be visible to me, and then I can relay that question on. But a couple of questions come in already, but they are very much about the things that we're probably going to be covering here, which is about the different subjects that people might want to take if this is a career that they want to go on to. So first of all, so just remind us again, what were your 3 A levels, Sarah?
So I did maths, physics and chemistry.
Which sounds like a very sort of natural and obvious set of subjects to do if you want to go into engineering. We know that some schools do offer engineering as an A level. I know there's not many of them, but I know that there's a couple of them. What would your advice be to anyone who's considering engineering as an A level subject?
I think absolutely, by all means, consider it, but I'm not sure you'll find an engineering degree course in the UK that does not require maths. So I would absolutely prioritise maths as your key A-level choice for any engineering course. Beyond that, I would say, depending on which branch of engineering, I didn't talk about like biomedical engineering earlier, actually, which is a big area, but then I would, if you can, I would add another science in there, so physics, chemistry or biology. For chemical engineering, both chemistry and physics are really useful, and then further maths is also going to be useful, especially to get into some of the top tier universities. So I would say it's not so much that an engineering A level isn't useful, it's just, do you have room for it along with the other ones that are perhaps required by the universities? I'd say engineering probably has the biggest number of A levels that it requires rather than are optional out of a lot of different subjects. So
okay, and you know, I've just had a fantastic question that's come in, and the timing of it is brilliant because it's a very sort of natural follow-up question to that. Is so the question is, how much of what you do is similar to the chemistry that we do at school, and perhaps extend that to application of maths and physics that you learn at school as well. So how practical and relatable are the things that you teach in learning those A-level subjects to what a chemical engineer would do?
Oh, you're challenging me because it is a little while since I did my A levels. But I would say that everything that I learned at university built upon the maths and the chemistry and the physics that I learned at school. So it was all extensions of it, and also combinations of it. So fluid mechanics, for example, is a core part of chemical engineering. Which is really a combination of maths and physics, and thermodynamics, also a combination of maths and physics. So yeah, I would say you build upon it. And then I would perhaps also add that I think chemical engineering or engineering in general might be one of the few subjects to study at uni where if you get a job in that sector, you're going to use your degree. So if you do an English degree and then you go on to your career, you're probably not that likely to use everything you learned in your degree. But in engineering, from day one in my job, I used what I learned. You know, I was going back through my notes of from my course to help solve the problems at work. So very much, yeah, a vocational option, you could say.
Sure. Well, I'll tell you what, just to help Sarah, just to jog her memory, if you want to just put in the question tab or in the follow question tab, some of the modules or aspects of chemistry that you're studying at the moment, just type them in and I'll throw them to Sarah and she'll try and relate them, I guess, to what she does now. We can get you a really full answer on that one. It's a really, really good question.
Yeah, brilliant.
Next question is, so just thinking here, so you obviously went to university. I mean, as you said, when you went, there was maybe 6 different universities that offered the program. There's probably more now, but is university a must, or are there apprenticeships that may be available that people could take?
So I've done a little research into this in preparation, and I've spoken to the Institution of Chemical Engineers, who I've been involved with in the past. And they've said that, yes, you can do an apprenticeship in chemical engineering, although at the moment there are not a lot of opportunities. In fact, I think there are probably more opportunities in the other engineering disciplines. So there are degree level apprenticeships available, but they are limited. And it's something that the Institution of Chemical Engineers is really trying to push to increase the number of those opportunities, because they recognise that that is something that students are looking for as an alternative. But at the moment, the majority of chemical engineers go to university. And I really think that having that grounding in those first principles is fundamental to your career as an engineer. So if you do an apprenticeship, you've got to find a way of getting those fundamental principles, that book learning, if you like, rather than just learning on the job.
For sure. Okay. And look, for those of you that aren't familiar with the concept of a degree apprenticeship, hopefully these are the sort of things that your school's talking to you about. I mean, probably depending on how old you are, you might find that whilst, you know, Sarah said there's not as many as the institute would like at the moment, that can change fairly quickly. So within perhaps 2-3 years, when you're finishing year 13, then you might find there are better options. But degree apprenticeships give you the opportunity to study for a degree whilst being employed by a company. So you get that real life work experience and you're getting paid for it whilst also studying for a degree. So we know there are lots of really good positive case studies of people that have done that and doing that. We've had a response, Sarah, to the question that we threw back, having answered the question. So some of the examples of things taught within the chemistry curriculum: organic chemistry, atomic structure, rate of reaction. So just for those as starters, are those things that you sort of have to be concerned with as a chemical engineer?
Absolutely, absolutely. Yeah, if you're designing a reactor to make a product, you need to know all about rates of reaction. If you're working with organic molecules, then organic chemistry is going to be key. So those things are very relevant.
Good. That's always good to hear. Sometimes there's a concern that you know, A-level subjects and GCSE subjects can be a little bit theoretical, but it sounds like things have been covered here are going to give you a real taste for what a chemical engineer does. I might struggle with a couple of the words on here, Sarah, so you might have to help me out. It's another really, really good question. This is related to what we do at the moment. So this is, I guess, there's another student. Do you do a lot with homologous series like alkenes and carbonic acids? Yeah.
Personally, I don't, but chemical engineers are going to deal with basically every type of molecule you can imagine that needs to be processed into something else to make a product. So I think any type of molecules or chemical structures or atoms that you're learning about in A level, you are going to be building on that at university for sure. Okay.
What is homologous series, Sarah?
I have to say, I have no recollection of learning about homologous series, but I'm sure I did. That's just my poor memory.
Yes, well, I can't even say it, but thanks. It's a really, really good question, and thanks for giving those examples there. So we're talking about university. We've spoken about the potential of a degree apprenticeships or apprenticeships as well that may come up. We always ask this question: what experiences could someone gain? I mean, obviously everyone would love to go and get a proper work experience working for a company like yours where they can actually see this in reality. But are there things that people could do? Could they sort of perhaps study or be curious with things at home or around the house or in their sort of day-to-day environment that are going to help them learn a little bit more about what chemical engineering is all about?
Yeah, it's a challenge, and it was a challenge for me when I was applying to study, is that it's pretty difficult to get, well, any work experience really, but chemical engineering isn't always easy. You don't always know a chemical engineer. So yeah, definitely ask around if you can. Like round here, we've got quite a few big pharma companies like GSK and Roche and Welwyn Garden City. So definitely that's the ideal, but it's not easy, and I don't think all universities are going to expect you to have work experience as a chemical engineer. But definitely check out the Institution of Chemical Engineers website. They've got a Discover ChemEng section on there, which you can have
Yeah,
a look at. And then also anything to do with, I think in your personal statement, they will be interested in any kind of design projects that you've done, like where you're designing a product to bring to market. There's probably some parallels with if you do business studies, that kind of process of designing a product to take it to market, and that all degree courses I think will have a design project in them, and it will obviously it will get very, very technical. So as technical as that project could be, would be interesting. And then I guess just any opportunities to solve technical problems out in the world. I don't know if there's volunteer opportunities you could look at, where you're helping to solve problems. I have to admit it's not an easy one to get engineering work experience, and that was a challenge for me as well.
sure. Okay. I mean, you said about volunteering. What sort of things could people volunteer on? What are those sorts of community projects that might just enlighten someone about the process of chemical engineering?
Yeah, oops. Yeah, that is definitely a challenge. Just trying to think.
Yeah, I mean, again, when you were growing up, you always saw it through the prism of sustainability and helping the environment, didn't you? So,
I
what were
did.
the sorts of things, if you were thinking about those as core intrinsic passions of yours, are there things that you might have explored, perhaps to volunteer on, or just as a hobby that would have been linked to what you now know as chemical engineering?
Yeah, so I have been involved as a volunteer engineer once I had my engineering degree, or during my engineering degree, so Engineers Without Borders. And I believe that Engineers Without Borders has some schools outreach activities. So it could be worth having a look on their website, that's Engineers Without Borders UK, to see if they have any school activities running or volunteer activities. Um, I'm struggling, I have to admit, to think in the community of many engineering projects, but I think looking at the websites of engineering companies and seeing what they're doing with schools, if you go for big companies, you're particularly going to find in big aerospace companies will have funds to do work with schools. So see what they're doing, if they've got any work experience schemes running. Summer schools could also be worth looking at if any of the universities run summer schools. I should have looked these up, to be honest, before this session, but it definitely would be worth having a look to see. I know some of the unis run summer
Mhm.
schools, and if there are any engineering ones.
Yeah. Okay, I'll put you on the spot there, Sarah.
Yeah, no,
So,
sorry about that. It's not the best.
I've just put into the chat, so hopefully everyone can see that the website that you've just spoken about, which is Engineering Without Borders, which is
That's the one.
www.ewb. So hopefully those of you that are on the call live at the moment can see that. There is another website link that we'll share with you before we close. Sarah, I mean, just moving on before we possibly get into some more questions that have come in. What I'm interested in is chemical engineering a job for the future? So is this something that there's going to be demand for, particularly when the students watching this come out of school? Is Hertfordshire a really good place to be? What do you think? Is there growth in this?
This was a massive consideration for me 20 odd years ago when I was choosing to become an engineer. Robots existed back then, even. And yeah, it was clear that robots or artificial intelligence were going to take away a lot of traditional career paths. So my assessment was that yes, chemical engineering is a future-proof career path. The industries that require chemical engineers are evolving. So historically, a huge number of chemical engineers were employed in the oil and gas industries, and they still are, but that is gradually decreasing. But in place of that, you're seeing engineers employed in various clean technologies, renewable energy, nuclear power employs a huge number of chemical engineers, and yeah, other renewables as well. And then just the absolute range of clean technologies that are going to be required, like electrolyzers for making hydrogen, and processes for making clean feedstocks for chemical processes. So yes, I think it's definitely a growth area.
Yeah, okay, so good things to go into. And then what are the other areas that people might go out into having been chemical engineers? I mean, you've obviously spoken about what you do, but do you find that people might start as a chemical engineer and then go into other branches of engineering, for instance, or are there other natural pathways?
Yeah, that's right. You might find yourself in a different kind of branch of engineering. So there might be, particularly if you go into renewable energy, there might be some crossover with mechanical engineering or electrical engineering, or electrochemical engineering, which is kind of perhaps a branch of chemical engineering, which is very much in demand at the moment because of development of batteries, but also electrolyzers. But if you've got a chemical engineering degree, it tends to be one of the more kind of rigorous degrees. You're going to come out of university with really good analytical skills, problem solving, data analysis, and those skills are going to be very applicable to other industries. So I think from my course at Imperial College, about half of the graduates went to work in the City of London for finance, consultancy, law, even banking. So a lot of different industries are very interested in engineering graduates.
Yeah. So yeah, okay, well, it's really going to broaden your horizons and give you lots of opportunities and pathways to explore. Okay, well, that's the end of my questions. We've had some really good questions that have come in as well, and I hope we've answered them. But you've still got a little bit of time, so if there's anything else you want to know from Sarah, you wanted to elaborate anything we've spoken about so far, then do get those questions in to us. I mean, I wanted to ask you, Sarah, you spoke about your passion for the environment. Do you find that true of other chemical engineers? If you think back to your degree course and some of your peers on that, was that their interest? Was that their hook into chemical engineering, or perhaps are there other interests that people may have that pull them into this?
Yeah, I think that's one of the hooks, but it's not the only one. I think another hook, inevitably, is that chemical engineers are relatively well paid. And so people are interested in that sometimes when they're choosing their degrees. So that was definitely the motivation of some of my my peers at university, and perhaps an interest in a particular area of chemical engineering, like food manufacture, for example, or renewable energy, or pharmaceuticals, if they might have been motivated by a particular industry which employs chemical engineers.
Yeah, okay. I'm going to share on the screen now with everyone a QR code to a website or a company that we've alluded to already. So, Sarah, do you just want to explain who iChemie are and what interesting resources people might want to go and have a look at on their website?
Sure. So iChemie is the Institution of Chemical Engineers, which is what we call a professional body. So the iChemie are the organisation who confer what we call chartership on engineers. So you can become a chartered engineer by applying to the iChemie and going through a process. So they are the people the organisation whose job it is to maintain standards within chemical engineering. So on their website, I would recommend having a look at the Discover ChemEng section, which is aimed at people considering studying or careers in chemical engineering. So I think there's a video on there and several like posters you can look at which explain what chemical engineering is and what chemical engineers do and what a career might be like.
Sure. Okay, so have a look at their website. There are, I mean, I'm not going to do them full service now, but there's lots of really good engineering websites that are out there as well that will help you explore engineering in its perhaps in its wider context. I'm going to take that screen down now. I think we're probably through now, because I think I've had all the questions that are going to come in. Just before we go as well, just want to encourage you, have a look at the HOP platform if you're not already familiar with it. Those are some of our social media platforms. I believe we've also got a TikTok account now. That QR code in the top left corner will take you through to all the previous webinars that we've run. So they run very similar format to this one. We've covered nearly 100 different topics now. So we've covered engineering. I think we looked at mechanical engineering or structural engineering and civil engineering a while ago, so there's information on there if that's something you want to explore. But there's a really eclectic mix. So within this academic year, we've covered careers as a film director. We looked at working in an airport. We covered one on visual merchandising just before Christmas as well. So even if it's something that you're not interested in, guarantee there'll be something in there that your friends will be interested in as well. So please direct them through to that, and then they can watch back these videos as well. We've got several sessions coming up. We have got, these are subject to confirmation, but looks like our next one's going to be about careers as a coder or software designer. That will be after half term. Hopefully we've got a session coming up about careers as a pilot, and also looking at careers in air traffic control. So we will cover, I think, something for everyone is all I can say on that one. So do have a look at it. Do make sure your friends are familiar with it, and do tell your teachers as well. We want them to be aware of it. There's resources on there for teachers too. So in closing, firstly, let me thank particularly those of you that have watched this session live and have contributed to it, and for reminding Sarah about some of the different modules within A-level chemistry as well, which by the sounds of it she's forgotten about. So thank you for sharing those with us. Thank you for educating me as well. A few more words for me to get right and add to my vocabulary. But principally, Sarah, thank you so much to you for giving up your time this afternoon and in preparation for this and sharing your experiences. I know you've been incredibly inspirational, and you've given some really, really great information based on your own experiences, and that's absolutely invaluable.
Thank you. Yeah, thank you for having me. I've really enjoyed it.
Great. Okay, so thank you very much. Enjoy the rest of your Thursday evenings, and we look forward to seeing you again very soon on HOP.